In the video for figure 6.14, we looked at a set of data which represents errors found in the recording of 600 medical records. We calculated the mean error rate, which was 0.776, and the standard deviation, and we graphed the data in terms of 1 standard deviation units, in this case only on the right side of the mean because the data is heavily skewed to the right. In this video we're going to look at the idea of the sampling distribution of the mean, and we're going to do this based on samples of size 30. If we took any random sample of size 30 from the data shown in this column, we would not expect to get exactly 0.776 as the mean of that data. Perhaps we would get 0.765. In another sample we might get 0.781. If we took enough samples, we would have a distribution of those samples around some mean value. To look at the nature of that distribution, we're actually going to draw using the discrete sampling option 250 random samples of size 30 to look at the result in terms of the distribution of the sample means and based on the standard deviation of the sample mean values. Now, to begin, in order to draw a discrete sample, we need probabilities associated with the errors. So each one of these values shown here is going to get an associated probability. Since there are 600 records, each one of these records will have 1 divided by 600 chance of being included in the sample. And I'll click this all the way down. So we have the errors and we have the probability of selection. So now we can go to Tools and Data Analysis, and we'll go to Random Number Generation, and it already says that we're going to generate a discrete random sample. I'm going to put in a random seed. Actually, that number is not random, but I'm putting it in so that if I want to replicate this same sample, I can do it again with simply using 1, 1, 1, 1. I'm going to take 250 samples, so in number of variables I will put 250. And for each of these samples I will have 30 observations, so under number of random numbers goes 30. Here is the request for the value and probability input range. This is the value on the left and the probability on the right, so Control-Shift down arrow gives the entire range of the data, the value and the probability. The output range is going to be a new worksheet ply, and when I say OK, I get a new sheet, and this sheet actually has samples of size 30, and there are 250 rows of these. If I go to the right, you can see that they go all the way out to cell IP. Cell IP is the 250th column. Now, first I'm going to calculate the mean for each of these samples. And there's the mean for the first sample. Interestingly, it's larger than 1. I'm going to drag this all the way to the right and I have the mean for each sample. Now, in order to look at the distribution of these sample means, that is, the sampling distribution of the means, I'm going to say equal average of the means, Control-Shift, right arrow, and that includes all of the means. And we can see that the average for all of the means is 0.76, which is relatively close to the 0.77 that we calculated for the actual population. I'm also going to calculate the standard deviation. This is again Control-Shift, right arrow. And when I hit enter, I get a standard deviation for the mean values of 0.223. What was the standard deviation of the original? It's 1.17. In a few minutes I'll talk about why these values are so different. But right now, let's move down. And just so we'll remember what these are, I'm going to put in mean here and STDEV here. And now I'm going to start with a -3, -2, and go down to 3. These are standard deviation units. Here I'm going to put bin values equal the mean plus the standard deviation unit times the standard deviation itself, and the standard deviation and the mean both get an F4. And now I will click this down, and here are the bins for standard deviation units around the mean of the sample means of 0.7624. Now I will find the frequency distribution equal frequency, Control-Shift, right arrow, a comma, the bins, and now Control-Shift, enter. And let's see if we got all of the observations. We'll sum this, and we only have 249, so there's one remaining, and it's probably at the top end. So we will move this down, move this down, and Control-Shift, enter, and we now have 250, so that there was one observation more than 3 standard deviations above the mean. But let's take a look now at this set of data in terms of the graph. When I go to next, I see that the data is not nearly as skewed to the right as the original data was. If I go to series and put in the standard deviation units and finish, this is my chart. Although it goes out on the right farther than it does on the left, this is much more closely approximating a normal distribution than the distribution shown for the original data, which is heavily skewed to the right.